an advanced manufacturing facility producing tilting trains. This specialized factory built
The active tilting system compensates for the G-force.
But we need to ensure the tilt-to-comfort ratio is optimized for higher speeds.
The pendular suspension concept explains natural tilting using passive gravity-based mechanisms.
Active tilting design develops computer-controlled hydraulic or electric actuators, precisely controlling tilt angle.
Tilt angle calculation determines optimal lean angle, balancing speed increase against passenger comfort, typically 8 degrees.
Car body construction utilizes lightweight aluminum, reducing weight, minimizing tilting actuator requirements. Aluminum extrusion produces structural profiles forming vehicle frame optimized for tilting operations. Specialized alloy
Tilt bolster fabrication manufactures interface between car body and bogie, enabling controlled rotation. Robust bolster.
Tilt actuator manufacturing produces hydraulic cylinders or electric motors controlling car body angle. Powerful, reliable
Electric actuator assembly constructs motor-driven systems, offering precise control and simplified maintenance.
Tilt control computer installation integrates processors calculating required tilt angle from track data. Gyroscope installation mounts inertial sensors measuring lateral acceleration and car body motion. Precise sensors detect centrifugal.
Accelerometer mounting position sensors throughout vehicle, measuring forces in multiple axes. Comprehensive
GPS receiver information provides position information enabling predictive tilt control. Satellite positioning allows a
Motion sickness mitigation addresses an elderly South Asian passenger's discomfort from excessive or poorly timed tilt.
Secondary suspension integration installs air springs providing isolation between tilting car body and bogies. Sophisticated suspension
Anti-roll bar installation connects left and right suspension sides, controlling non-tilt roll motion. Stabilizer bar. Damper system installation integrates shock absorbers, controlling tilt motion and preventing oscillation.
245.24. Emergency tilt safe operation ensuring sensor. Bogie design accommodates tilting mechanism while providing stable platform for traction and braking. Specialized
245.26. Wheel and axle assembly uses standard components compatible with conventional.
245.27. Traction motor installation mounts electric motors driving wheels providing propulsion. 245.29. Panther installation mounts current collection system compatible with existing
The interior construction provides a premium passenger experience with comfortable seating and refined finishes.
That's the tag.
Resonance. HVAC equipment mounting installs powerful climate control, maintaining comfort despite varying passenger loads. Effective air.
Is the express service to Central Station. Our advanced tilting technology ensures a comfortable ride through the curves ahead.
Accessibility features ensure universal access, including wheelchair spaces and priority seating. Inclusive design.
Tilting system engaged. Monitoring bank angle on screen 3. Readings are stable. Clear curve ahead. Well done.
Static tilt testing verifies actuator function and control system operation without motion. Initial testing.
Dynamic tilt testing operates train on curved track, validating tilt angle accuracy and timing. Comprehensive testing.
Human factors testing ensures tilt algorithms minimize nausea and discomfort, optimizing passenger acceptance.
Speed limit testing determines maximum safe curve speeds with tilting active. Systematic testing is appropriate speed increase. Emergency response testing validates safe behavior during sudden braking or system failures. Comprehensive safety testing ensures
Reliability testing operates tilting systems continuously, identifying potential failures before delivery.
Right up. As you can see, the Series 245 achieves full tilt at this velocity, well within the safety parameters.
Excellent demonstration.
245.52. Technical documentation supplies maintenance manuals and tilting system operating procedures.
Okay, engage the tilting mechanism now and observe the stabilization protocols on the main screen.
Tilting system active, we have a smooth transition at speed.
Reversing that valve. After servicing the actuator, we calibrate the sensor array.
245.4 training 5.5. Route familiarization traders on specific curves requiring attention.
The system effectiveness is fully validated. See the green across the board.
Yes, and that yellow highlight confirms the optimization area.
Journey time reduction demonstrates tilting benefit, reducing travel time compared to conventional trains. Time savings just
fine.
British advanced passenger train attempted early active tilting, though reliability challenges limited success. Pioneering APT development advanced tilt.
Japanese tilting trains serve mountainous routes where conventional trains are limited by tight curves. Tilting technology is particularly valuable in Japan.
The Swedish X2000 demonstrated high-speed tilting serve.
Infrastructure savings justify tilting train investment, avoiding billions in track reconstruction, substantial infrastructure cost avoidance.
Operational flexibility enables serving routes with mixed curvature using common fleet. Tilting capability allows single
Tech tendency. Environmental benefits reduce journey times, encouraging modal shift from automobiles and aviation. Faster rail service attracts at
245.68. Energy efficiency improvements result from maintaining higher speeds, reducing acceleration and braking cycles, sustaining high.
Honestly, I didn't think we'd get here this fast.
And so smoothly, too. It's much better than flying.
Technical challenges include maintaining reliability of complex hydraulic and electronic systems. Sophisticated tilt
245.71. Maintenance complexity increases costs compared to conventional trains.
Initial reliability concerns plagued early tilting trains, requiring extensive development refinement. Early operational difficulty.
245.74. Cost considerations balance higher vehicle prices against infrastructure savings and opulent 245 tempo 7 road supervised applications and baby surge and quit suits replicated ventural train filter suit tilting with technology
300.4 205 with 5 root point per 76. Speed improvement typically enables 20 to 40% increase through
Future development continues advancing tilting technology, improving performance and reducing costs. Ongoing research.
Lightweight materials research explores composites, reducing weight and tilting actuator requirements. Advanced materials promise.
Sensor advancement improves curve tilt control accuracy. Better sensors and gas and
Algorithm optimization refines tilt control, reducing motion sickness and improving comfort. Sophisticated control strategies promise improving.
Integration challenges address as tilting system interaction systems. Ensure shelf
245.8 45-point rain requirement. Safety certificate requirements demand rigorous testing and documentation.
Standards development establishes guidelines for tilting train design and testing. International standards facilitate technology.
245.86. Interoperability considerations address operation on multiple railways with varying.
Gauge adaptation enables tilting trains operating on different track gauges. Variable gauge capability combined with tilting provides
Platform line shortens tilted trains don't strike station studies.
245.90. Bridge considerations address dynamic effects of tilting vehicles.
Under 245.993. Maintenance facility adaptations accommodate
245.94. Spare parts provision establishes inventory supporting tilting system maintenance.
Life cycle costs analysis compares total ownership expenses against conventional alternatives. Comprehensive economic evaluation.
Market success stories demonstrate commercial viability of tilting train services. Profitable operations in Italy.
245.97. Ridership growth reflects passenger preference for faster tilting train. Tilting trains are winning market share from airlines and automobiles. Faster journey times enable rail to compete effectively.
Network effects multiply as more routes adopt tilting technology, creating comprehensive systems.
Export opportunities generate revenue through international sales of tilting train technology.
Domestic manufacturing supporting
Innovation culture promotes continuous improvement, advancing tilting technology capabilities, sustained research and development.
On Zutulard at 245.105. Knowledge preservation documents expertise supporting continued production and improvement. System.
Ensure the caliper is zeroed before measuring the actuator rod.
It's reading within tolerance, 75 millimeters exactly.
Excellent, the data confirms it.
We have an anomaly on the high-speed line. See the fluctuation here?
Rerouting the sequence through the auxiliary grid. It's stable now.
We are truly honored to accept this award for technological innovation and engineering excellence.
Customer satisfaction reflects positive railway experiences with reliable fast tilting services, successful operations.
Environmental leadership demonstrates railway commitment to sustainable transportation through efficient technology.
Urban congestion relief reduces road traffic as tilting trains attract diverse automobile travelers. Competitive rail service encourages
air quality improvement results from reducing automobile and aviation travel through rail. Cleaner electric trains attract travelers from polluting modes, improving regional.
Tourism promotion uses distinctive tilting trains as attractions and convenient access. Modern tilting trains enhance economic integration strengthens through faster connections between cities and regions.
Social inclusion improves through affordable fast railway connections, providing mobility supporting social cohesion and economic opportunity.
Future potential anticipates broader adoption as technology matures and costs decline. Continued development promises making tilting trains more affordable.
Alternative applications explore tilting technology for metro and commuter services. Urban applications could bring tilting benefits to shorter distance rates. Freight applications investigate tilting for higher speed freight services. Adapting tilting technology to freight operations could Technology convergence combines tilting with other innovations like predictive maintenance, integration of multiple advanced
here. 245.125.
Sustainability focus drives lightweight materials and energy-efficient tilting mechanisms.
Legacy appreciation celebrates decades of tilting train innovation and operational success. Recognition of pioneers